Hey everyone, I hope you all are safe and doing good. So now in the previous lecture we have seen what are arrays, the basics of arrays, and in this lecture we'll see what are some operations we can perform on arrays. There can be many operations: traversal, insertion, deletion from the array, searching an element from the array, sorting of an array, copying the element of one array to another array. There can be like this. There can be many more operations. So for searching and sorting, we have like special algorithm. For searching, we have linear search, binary search. For sorting, there are so many algorithms: bubble insertion, quick merge, and many more. So those things we'll be discussing in separate videos. In this lecture, we will see the basic operations. So the traversal, insertion, and deletion. These things we'll see in this lecture. Traversal, we have seen actually traversal is nothing but in the previous lecture also we have printed the array, right? So if you have an array, you have inserted some element and then we have printed the array using for loop and for each loop as well. So that is nothing but like traversal. Traversal means visiting each element of the array exactly once in a sequential manner. That is nothing but traversal of the array. Means you are traversing the array from starting to end, all the elements. Okay. And it's not like that while you are printing the array, then only you can do traversal. We need traversal of the array in many times, while inserting as well, while deleting, and for all the operations. I mean, the traversal is the basic one. Okay. So like if you have an array, in this array I am having some element 3 and other we have 0 0. So only 3 elements we have, so remaining elements would be by default 0 0. We know default values. So suppose array size is 4 5 6. Actual, so you can say capacity of the array is 6, but actual element we have stored is only 4 elements. So remaining would be by default 0 0. We know. Traversal means you traverse the element from this to this, then this, exactly once in a sequential order. So that is traversing. So I hope that is very simple. While printing, we also like traverse the array. So it's like you can just need a loop. We'll start from the index 0 and till here we have only the elements till the actual size. So you can say actual size of the array is 1 2 3 4, and this 6 is nothing but like capacity. Or we can say at first only we can do something like this. We have an array int arr, and initially I have taken the size 100. So let's just write down this thing in a separate line here. Here I am having arr is equal to new int and 100. So maybe in future I have to use like 100 elements. So I have reserved the space because I know arrays are of fixed size. Once at the time of creation you have fixed the size, you cannot change it dynamically. If you want to change, then you have to allocate a new array of the different size and you have to copy the element of this array to new array, and this operation, obviously this would be like a little bit time consuming process. So at first only I assume that maybe I need in future 100 elements. So maximum capacity I have given 100, but right now I'm just using only 4 elements in the array. Okay, 100, 200, 500, as much capacity as you want. So you have given the space of how many bytes? 100 into 4, that is 400 bytes, and you are actually using only this. So actual size is only 4, but total size of the capacity of the array is 100. Okay. Now, okay, all the elements we know that arrays are stored in contiguous memory location. But one thing I just want to tell you, yeah, conceptually we is, imagine this thing in Java, C and C++. We can say that arrays are stored in contiguous memory location. But I have told you that in Java, arrays are actually objects, right? And objects are created in, we know, heap. So there is some heap memory, and we have stack. So it's like the array name is what? ARR. So it's ARR, and this is referring to here. Here we have the array from 0 to 99 because the size is 100, so 400 bytes would be allocated. But we have like till 99. So heap memory, according to that JLS, Java language specification, heap memory itself is not contiguous. It's not like that because JVM internally handle these things, these memories. Operating system allocates some memory to JVM and JVM handle. If JVM needs some extra memory by chance, so it requests to the operating system and then some more memory would be allocated. And once the memory is freed, then you can say that once you are not using any object, we know that there is garbage, there is, you can say, automatic garbage collector in Java, automatic memory management. So that garbage collector will basically free that space and like this, unused space. So because of this fragmentation and this kind of thing, heap itself is not contiguous block as a contiguous block. Okay, it itself is fragmented actually in Java. But Java abstract memory management from us. So we don't know much about memory management like we know in C and C++. We deal with like memory with pointers and all. So we can say that, yeah, these arrays are stored in contiguous memory location, but it is not the case in Java. It depends on JVM. Actually, it's not a guarantee that 100% every time like these are stored in contiguous memory location. Java JVM can do some trick with these things. Okay. But yeah, we assume that for primitive arrays, these are stored in contiguous memory locations. Like first we have 10, then we have 1, then 2, then 3, and like this data would be stored in contiguous memory location. But we know that when you are creating arrays of objects, in the previous lecture I have told you, so in that case it is not the case. If arrays of object is there, then here itself this is a reference array, right? And this array is of array of references. Suppose there is a class, let me just give you one example, a class student. The previous example also only take. And if you create array of objects, so student and name I am taking students is equal to new, and after that, after new just write like student, and the size of array is 5. So this students is a reference, it's array of references to the actual student object. So this is like students array of references, and this is array of references, size is 5. So 0 1 2 3 4, something like this. But this is actually containing actual object or somewhere else in the heap. You have to create, and these are also containing references of those actual objects. We know it is with array of objects, and these objects are not necessarily these are contiguous. These objects can be anywhere in the heap. Suppose this object is starting from here, we have name and roll number, so it will contain name and roll number, and starting from 1000, this may starting from 5000, this may be starting from maybe 3000 or something like this. So these are definitely not contiguous, we can say. Okay, this reference arrays, we can say it's contiguous. But yeah, conceptually, we assume that arrays are also stored in Java contiguous memory locations. At least for primitive arrays, we can say. Primitive data type, having primitive data type like int, float, bool, and all the primitive types. We cannot say this for arrays of objects. Okay. So when I say the formula to calculate address, that base address plus index into that kind of thing, so that we theoretically assume, conceptually we assume that okay, this is how like it is to be calculated, but we cannot say it's 100% guarantee that arrays are stored in heap memory in Java by the JVM in contiguous memory locations only. Okay, but yeah, we assume this thing conceptually that this is stored in contiguous memory locations. Okay, but actually it depends on practically on the JVM, how JVM handles internally this thing. We cannot say surely, because Java is like abstract this memory representation from us. Okay, so now this is traversal. From we move from 1 till whatever the length of the array. But here length of the array is, suppose we are taking size is 100, so length of the array is 100, and actual size, actual data is only 4. So why to run the loop till 100? Yes. So maybe there is maybe a case that you are given a size another element size, this is 4, so you just run the loop till, not length, till the, you can say, size. So size is 4, so we run the loop till 3, I mean less than size, and just print this. And if size is not given sometimes, so you can do one thing, you just count the number of elements in the array with the for loop simple. I'll do practically this thing. So first count the number of elements, store in that a variable count, and just run the loop till count, that's it. So it depends how the question is given to you. I will explain all the possible all the possibilities of answering the question. Maybe interviewer can ask this type of question in a different way. Size is given, size is not given, and this kind of thing. Okay, so simply traversal, I hope you got this. We will see practically, don't worry. Now let's see next. Next, we have insertion. Now, insertion, let me just explain. Insertion can be at the beginning, at the end, and at any specific position in the array. So, we have an array. Suppose size is 20, maximum size we have taken. So, 0 to 19 indexes. And suppose we have only 10, 1, 2, 5, only 4 elements or 6, 5 elements. So, actual size is only, we can say it's 5. Right, only 5 elements are there. Remainings, in remaining, obviously we know that 0 0 0 by default 0 0 0 is there. Now we can insert. How to insert? See, I've told you in the previous lecture, when you need frequently insertion and deletion in the data, we don't prefer using arrays, we use linked list or array list. Why I'm saying that? This, once you get this thing, insertion and deletion in array, then you will get the answer of this thing. Okay, because these are like having you know very expensive in terms of computational cost or time complexity. Now, insertion. So, one thing is, I assume that size is given to you. Size is 5, and this is the array, and I am having this much of data here. Okay, this is the data. First thing, I want to insert at the end here in the array. So, how you can insert? So, you pause the video and think. I want to insert at the end of the array. At the end means not here. Obviously we are not inserting here, because it's not like that we have some data, then gap, there is no data, and after that we inserting. No, it's not like array we assume that stored in contiguous memory locations. So 5 here you can insert. This is like considered as we are inserting at the end of the array. Okay, how to insert here? It's very simple. We know size is 5, right? So index would be obviously 0 till 4, because size is 5. Now simply you can insert like name of this, and here you can give size, because size is 5 at the end. So size is 5. So here 5 index would be 5 is equal to whatever element you want to insert. Suppose I want to insert x, and int x is equal to maybe 20. Simple, and you just do size plus plus. This thing is very crucial. Increase the size. Don't forget that thing. Okay, because when you traverse the array, if size is still 5, so we generally traverse from 0 to size. I mean less than size. Less than size. So it will only print till here. It will not print the next element. So increase the size. Previously size was 6. After inserting, size is 6 now. Previously it was 5. Sorry. And now it's 6. So it's very simple if size is given. Can you tell me the time complexity of this? It's very simple. Just order of 1. You simply access this, and in a constant time you can insert. So this is the best case, right? You don't need to traverse the array. This insertion doesn't depend on number of input or the elements in the array. Nothing. It's not like that. Okay. We know the size, it's given, and directly insert. If the size is suppose 10, suppose there are 10 elements. So 0 to 9 we have inserted. At the end you want to insert. Same, you want to write array size is equal to x and size plus plus. That's it. So here the time complexity, the number of operations going to perform in this case is obviously for each line. For a complete program it may be order of 3 4, because there are so many lines, but definitely it would be order of 1, like constant. Okay, generally we write here the degree. So it's like we can write here something like this. It's 1, or maybe suppose for the complete program it's order of 5. Suppose order of 5, but 5 we write here n, keep n to the power 0 in the form of uh, n. We write this because it is as a function of input size n, but here n is 0. Okay, and n to the power 0, it's like constant 1, so that's why we take it 1 actually. Okay, something like this is happening. So yeah, you got this. Space complexity is also, we are we taking any extra element to solve the problem? No, we are not taking, I think, any extra kind of thing. We have X you want to insert, we have array and all. So the overall complexity is input space plus auxiliary space as order of n only, or exactly order of n plus some data 2 or 3, because you are taking X, so it's for order of 1. For array it's order of n, and one more we are taking, no, we are not taking anything, so it's maybe order of n plus 1, but generally we know that we ignore constants, so order of n. Okay, for the complete program, for just this operation it's order of 1 only, space complexity as well. Okay, if you consider only the auxiliary space under space complexity, then it's order of 1 only. If you take the complete thing, input space plus auxiliary space, then in that case order of n only, order of n. So this is the best case. Okay, worst case is I want to insert in the beginning, then what will happen? So let's assume this, let's try to find out this. Now I want to insert at the beginning of the array. Now suppose there is a queue in the ticket counter, and maybe there's a ticket counter here, there's a queue, we have 20, like 20 people are there, and suppose here you come and you see that, oh, the queue is long, so maybe here you have your friend, so you go there, you ask your friend, I just want to stand here, please do something. So your friend say, okay, let's do one thing, you will just stand up there, and everyone would be pushed backward one position, something like this. Okay, so this is how actually happening. So everyone has to move one position backward, back, if you want to stand here at the first position. So same thing happen here. Now if you want to insert in the array here at the beginning, what will happen? If you simply insert, suppose, okay, we have int x is equal to 20 and I want to insert here, so you say that I will simply write here ARR of 0 is equal to 20 or x, simple. What happens here? ARR of 0 is x, so here it would be 20. Now you 10 is 10 is no more in this array, but that thing we don't want. We want all the data plus I want to insert 20 as well. You have to do this thing. So see, there can be two cases here in this case. There can be two cases. Now in case one case may be if the order of the element matters. If interviewer or someone asks that, you have to preserve the order of the element as it is. Means first we have 10, then 1, then 2, then 5, then 6. This order should be as it is in the array. You can't, you can say, alter this order. So what to do? Okay, there is one option left only in that case. So we can just do one thing. We can put 6 here, 5 here. We can just shift these to the right. 2 at this position, 1 at this position, 10 at this position. And now insert 20 here. So we have kept the order as it is and we have inserted at the beginning. Yes. Case second, maybe someone say that order doesn't matter. So it's like we can say, okay, if order doesn't matter, in that case, we just shift this element at the last here simply and insert here 20. That's it. You don't have to change, you don't have to like move these elements, remaining elements, you just have to remove or move one element only from beginning to last and insert here 20. So there can be two situations. Okay, first situation we'll discuss, if you have to preserve the order, you cannot change the order, in that case what you will do? Okay, fine. It's very simple. Now you can pause the video and now you can just try to think the logic and write down the logic here. It's not that much tough. Okay, now here let's do one thing. You have to shift. Now we have something like this, so you have to first shift these elements and then you can insert. It's not like that first insert and then shift. No, as soon as you insert, this 10 would be lost, right? So the better idea is first make a space, shift these things and then insert. So we size is here, size is what? Size we have is 5, because there are 1, 2, 3, 4, 5 elements and Capacity is 20. So size is given to you. Suppose I just consider that size is given to you. Size is 5. Right? Now, have to insert. So let's, what to do? You have to run a loop. I is equal to, you have to shift this from this. I mean, here to here, something like this. So we can run this loop. We start from here and we will be running the loop till here, till here. Right? Because first you have to shift 6 only. So you have to start doing some processing from the last. Okay, you cannot shift from, let's shift 10 to here. If you shift 10 to here, then 1 would be lost. So shift this. So from the ending only you have to do some processing. So ending means from here, so you have to move backward. We know. So loop would be starting from here and moving backward till 0. This is for sure. So I would be, I is equal to whatever the size. Size is 5. So right now size is 5. So I is at this position here. Okay. I greater than 0 and I plus plus. Don't worry if you don't know. Like I should be less than, greater than 0 or greater than equal to 0. You just try out. You practice. When you run the program, maybe you get some error or you not get the exact output. Again, debug the code, try run this and you will get that thing. Okay. If at the very first you get exactly same, if you not make the mistake, you will not learn. That is for sure. Okay. So make mistakes, do some mistakes, learn from your mistakes, practice, try run, and then try to find out what will be the exact condition here. Okay, let's suppose I am writing greater than 0 because obviously roughly we have to run till 0 only because we are inserting at the beginning. Okay, one thing I generally make this mistake is we are moving backward. I starting from here till 0. So we cannot do I plus plus. It has to be I minus minus. I minus minus. This you need to take care. Okay, now ARR of I. ARR of I is, because I is 5, so this is equal to whatever is there in the ARR of I minus 1. Just move to the I, that's it. Simple. And after that, what you need to do? After shifting everything, then we simply write here ARR of, at the beginning you want to insert, so simply you can write here 0 is equal to whatever the X is. But you have to do size plus plus, that is compulsory. Okay. If you dry run this thing, so it's very simple. Dry run is very important. Please dry run every code, at least for starting, please. At first, we know that I is size is 5. So I is 5. Condition true? Yes. Control enter here. Now, ARR of 5. So we say that ARR of 5 is equal to ARR of 4. So what is there in ARR of 4? 6. It would be moved ARR of 5. Means 6 would be now here. Yes. I minus minus. Now I becomes 4. Condition still true? Yes. Enter here. Now, array of 4 is equal to array of 3. So whatever in this 3 would be shifted here. So here now we have 5. Yes. I minus minus. I is 3. Now what happens? It's 3, this side 3 and this side we have 2. So ARR of 2 is 2 and this we have to move. We have to assign this to ARR of 3 here. So this becomes now 2. I becomes now minus minus. So I becomes now 2. Okay. Now at this time ARR of 2 is equal to ARR of 1. In array of 1 we have 1. You have to shift assign from here to here in array of 2. So this becomes 1 now. Now I becomes minus minus, then 1, condition still true. Again enter and one more time. It's 1 and this time here we have 0. So whatever in at the 0th index, shift to 1 index. So here we have now 10. Now I becomes 0. Do you need any shifting kind of thing now? No. So that is the condition. I should be greater than 0. If I become 0, stop. Condition not true. Okay, out of the loop. Now, okay. Now here we have 10, here we have 10. So obviously we can insert here 20. ARR of 0 is equal to 20. That's it. Size plus plus, now size becomes 6. And we know now size becomes 6. Time complexity for this, I hope you got this method. Time complexity now. Main logic is this only. this one for loop. Okay, and if you want to print the array after inserting, one for loop for that, so that would also run n times. But mainly to insert, if someone asks, printing is a different thing. For a complete program you can consider printing, but mainly for inserting at the end, what is the time complexity if you follow this approach? If you have to preserve the relative ordering of the elements, is in that case you have to shift every element there. So this is the worst case. Whatever the element in the array, whether it's 20, 100, 50, you have to shift all the elements the right side. So you have to traverse, there would be n iteration, whatever the size of the array, till that this loop will run. Size of the array means obviously the size of the array, whatever the size. So we consider it in general n. So this operation would be performed. How many number of operations? Obviously this loop will run order of n in general, if I say. So bigger notation, the worst case, the time complexity for this operation is order of n. Specifically, exactly, if you want to calculate, then order of n plus, for this also we have order of 1 for executing this, order of 1, and there may be some more lines in the program. For those also we have constant time complexity. And if in the program you are printing, then for that loop also we have order of n. So it's order of 2n plus order of, I guess, 2, but we can just ignore the constant, so it would be order of n only in general. Okay, this is the main thing. This is the drawback of insertion. In the worst case, you have to shift every element. Suppose there are 500 elements, 1 million elements. So obviously the shifting of these type of elements is definitely costly in terms of computation. There are so many computation. So there should be something we can directly insert where you want to insert. There would be no moving of the element and all. So for that, we use either array list or linked list. Okay. So this is a- at the beginning how you can insert. But one thing, if suppose size is not given to you, only this is given 20 elements, and I have inserted some elements in there is some space are unfilled space, and there are only like 5 6 elements. The size is not given to you, how many elements are there actual element, then what you will do? Obviously we will not run the loop from the length, because here are we have 0 0 0. We only care the actual data, whatever the elements 5 6 7 8, for that only. So for that, first you have to count the number of elements in the array, and then simply you can just do whatever you want to do. If you have counted the number of elements, means you get the size, and then you can do the same thing. Have to count, that's very simple. You just traverse the array, and if element is found, just do plus plus, count plus plus, simple. But you need to add some one more for loop for that. So for that also complexity would be order of n, computation would be increased. But yeah, it depends what you are given in the problem or what you have to do. It depends on that what you need to perform. If size is given, you don't need to count the number of elements. Practically I'll show you how to count number of elements. Okay, so now if third case is I want to insert in the array in a specific position, at a specific position. So now in this array, suppose this is the array and I want to insert here, not the beginning, suppose here, at any specific position here. So sometimes they consider position and index same. Means I say that I want to insert at index second. Simple, this thing. At index 0, I want to insert. At index 4, I want to insert. So whatever the position is there, it's considered as same as index. But sometimes position is different, index is different. Position is considered like this. Position 1, 2, 3, 4, 5, 6, and 20. This first element is at position 1. Index is 0, position is 1. So if I say now I want to insert at position 3, means you have to insert here at index 2. So it's your wish, or it depends on the maybe the question what is given. According to that you have to solve. But in this video I assume that position is different, index is different. If position is 3, So this position means index is 2. If position is 2, means this thing, and index here is 1. So index is different, position is different. I consider for this video this case. Okay. You can modify this according to yourself. If you want to consider both the things same, that is also fine. But actually, it depends on the given problem, right? Now, I want to insert here. The position is here. So position is 3. How to insert here at position 3? We cannot simply say ARR of position insert element. No, you will lose this value too. Same thing you have to, same process. Whatever is there at the right side of this position, just shift these a little bit. I mean to the right side, something like this. And then insert. Yes, that's very simple. So I guess you can easily write down the code for this. And suppose size is given to you. Let's consider size is given. That's 1, 2, 3, 4, 5. Array capacity is total length is 20. Size, actual size of the array is 5. Okay. And there is no way to calculate actual size. I mean, for to calculate length, we have a inbuilt length field. We just write the name of the array dot length, and it will give you the length of the array. But there is no something like this, like ARR dot size, and it will give you the actual number of elements in Java. No, there is no such thing with regular arrays. So to count this total number of elements, if this kind of thing is there, there are some unused space. You have to count the number of elements with for loop yourself, right? Now we suppose we are given size. So what we do is we have to shift. So from here, something like this. So obviously we will start shifting from here only. We know at the end. We cannot start from here, because if you shift at the starting 2 to here, then here we have 2. So 5 would be lost. So better we start from here. This is common sense, I guess. You got it. Here we have 0, 0, 0. So we start the loop something from here, and we move till here, till the position. Not till 0, till the position. That's it. So we start I is equal to whatever the size, I guess size is 5. So start from here. I is at first here. Till I greater than equal to position, I guess. So position is, here we have 3. 3. Let's see it will work or not. And I minus minus. Maybe you have to change the condition. I don't know. Once we try run this, then we will get it. Let's run this now. Let's write down now. Now, how you have to shift? ARR of I, here we have I. ARR of I is this, because this is a 0. And you have to shift ARR of I minus 1. So from I minus 1 to I. This is the assignment now. From this to this. And this exactly we want. Till here. Okay. As soon as you come to the position, then just insert here. Position, here you want to insert. So position is 3, but index is 2. So here it should be position minus 1 is equal to whatever the x value. We have here int x is equal to 20, and that I want to insert. And size plus plus. That's it. Let's write on this and see. At first we have I is equal to size. Size is 5, given is 5, so I is equal to 5. Condition true, because position is 3 and index obviously 0, 1, 2, 3, 4, 5, and size is 5. So condition true, greater than equal to position, yes. Control will enter here. Now here we have ARR of 5 is equal to ARR of I minus 1, that is 4. So whatever in the 4, we assign here at the 5th location. So here we have 6. Yes. Now I minus minus, I becomes 4. Condition still true? Yes, condition still true. Okay. Control will again enter into this loop. And now this side it would be 3, this side it would be 4. So whatever at the 3 index would be shifted to 4. So now here we have 5. Again minus minus. So it becomes 3. Condition still true, because position is 3. I is 3. Both are equal. Condition still true. Okay. It's good. Control will again enter into this loop, and this would happen. Whatever is there at the ARR of 2 would be shifted to 3. So here we have now 2. That's it. We are done. We don't need any other shifting because we are here 2 and 2, and this 2 we don't want, so we can easily insert here. Now this becomes 2. Is condition true? No. So our condition is true. I mean, our termination condition is correct. You have to do the shifting till here only. Now we are done with this. So condition is not true, so control would be out of the loop. Now ARR of position minus 1. So position is 3. 3 minus 1, 2. So ARR of 2 is equal to whatever x, 20. So ARR of 2, here we insert 20. That's it. And size plus plus. And that's exactly we want. Yes. Now what would be the time complexity for this? Pause the video and find out. So any specific position. The worst case is suppose the specific position I have given this from the beginning only, or from this here. And in the array I have 500 element. So obviously almost 500 element you have to shift right. So we can say n number of operations are to be performed. This line would be executed like almost n number of times. Maybe if we are shifting this and there are 500 element in the array. So maybe you have to shift only 498 elements. But that doesn't make exactly any sense. 500, 498, it's not that much difference when we are dealing with huge data like 1 million record. So 2, 3, 10, 500 record, these are not making any sense. So we in general we consider that obviously the loop will run till order of n, I mean n number of times. So this would be n number of times. This line would be executed n number of times. So order of n. Maybe this can take order of 1, this can take also take order of 1, but these things we don't consider while writing bigger notation, while writing the worst case. So same, this would be order of n. Space complexity also, there is no extra element we are taking here to solve the problem. So it's order of, only the input size is array. So order of n only to store that array. Auxiliary space here is, I guess, nothing. Okay. Okay. There is auxiliary space. We are taking extra element, extra variable I. So for this order of 1. So auxiliary space is order of 1. And position also we are taking, I guess. So you can consider this also. Otherwise, order of n for input array. Okay, I hope you got this. So this is how we can do insertion. And same here, if size is not given, then first calculate total number of elements here, then do this kind of processing. You need one more extra for loop in that case. Okay, but don't forget to increase the size after inserting. And if suppose position is given 19 or 10, what do you think? We have size till 5, so till here we have element, and here we have some 10th position obviously. So is it valid? We can't say, we can't insert something like this an array. Like there is some data, then there are gap, there is no data, and then we have again data. No, this is not allowed. So first check the position is valid or not. So position must be, you can here write down one more if condition before this. If position less than equal to 0, 0 is not allowed because I am taking position from 1. So 0 is also not allowed. If you take index and position same, then 0 is allowed. So less than this or position greater than the size. In that case, you write here position is not valid and something like this. Greater than size. If I say suppose size is 5. Here till here we have elements and here we have 0, 0, 0. Can I give position is equal to 5 in this case? Yes, we can give. Position 5 means at this position 1, 2, 3, 4, 5. Here I want to insert. That's allowed. Can I give position 6? Yes, we can give. Position 6 is this. This would be considered as at the end of the array. That's allowed. But greater than 6 is not allowed. So size is allowed. Size is 5. 5 is allowed. 6 is also allowed. So we can say plus 1 is also allowed. But if it's greater than size plus 1, that is not allowed. So exact condition you can write something like this for position. Okay. So now let's discuss practically. Let's write down code for this insertion and traversal, and then we will discuss deletion, right? So in a data structure and algorithm, this project, let's create a new class and we are discussing operations. So let's name it operations on array. This is my class, and let's take at the very first an array. So suppose I have this array and I have just inserted these elements in the array. And suppose size is given to me int size is equal to 5. So actual size of that is 5. Capacity we can say it's 10. We can insert 10 elements. Right. Now let's traverse the array. Let's print all the things. So for this, let's make a method suppose traverse array. And what you want to traverse this array. So how to pass? We have discussed how to pass uh, arrays in the methods as an argument. You just have to write simply this array, the name of the reference. So ARR, simple. So for that, obviously, you have to define first. Let's make it static and void the method. And if you are passing this is a reference, so obviously have to create the reference. This is the line. Simple. So just have to create here ARR of 1. Suppose we are taking ARR of 1. Okay. So we have created this. So the reference is like address. In Java, just make sure everything is called by value. There is no call by reference. So in ARR, suppose the address we are having, I'm not sure. I'm just taking any like this value for simplicity purpose. Suppose 100. It's some hexadecimal kind of thing and we don't know actual address. What is this? So this value is to be passed. So here it means 1000 would be passed. So here also we have a reference variable in the stack, and in ARR1 also now we are having 1000. Means this data is somewhere in the heap. At first in stack there was ARR pointing to this data, and now in ARR1 also there in stack same pointing to this data in heap. Okay. So exactly we can access the actual data with this. We are passing the by value. So in Java it's called by value every time. There is no call by reference. The value is to be copied here. See 1000 was there. Here this was copied here 1000. So now it is pointing to the same object in the heap memory. So we can just directly access this thing and we can modify this array. Right? And now this is how we pass array. I guess you remember this thing, we have discussed this while discussing our Java course in Java. Now traverse the array. So you just traverse means simply start from 0 and exactly once visit all the elements. So I would be less than whatever the size given. Okay. Now size is not, you have to pass the size as well if size is given. So we have to pass the size as well. Okay. So there we need two parameter. Actually, these are parameters and these are arguments. While calling whatever you are passing, the actual thing, these are arguments. And in the definition of the function, these are known as parameters. So we have size. Same name also you can take. Doesn't matter. So till size. Not till length, till size. Because length can be, suppose length can be 1000. We have only only five element is there, but the length is 1000. So don't no need to run the loop till 1000. Till size only run. Okay. Don't waste the space. Let's make it 10 only. I plus plus and we know we can simply print how to print this. ARR1 and whatever the I. Simple. That's it. Better to write here print only, not print ln, to print everything in symbol same line. So if you run this is simple traversal of the array. I guess it's not that much stuff we have discussed in the previous thing also, but for traversing we know we use for each loop rather than traditional loop. So yeah, we can use that also. For that you have to write down int I You can take any element where the name of the array is ARR1 and no need of the control variable. We can simply print whatever the I, because I is not the control variable here is the, it is having the actual data of the array. If I run this, it will print whatever the element is. So for each loop is, I guess, better. It's not better, the previous one, this one. But what happens here is it will print this the complete, because we are passing ARR and there we have the length is 10. Actual data is 5 only, but remaining 5 is 000. So it will print this data as well as 0000 because we are passing the ARR1. Okay, so it will point to this unused space as well as this. And here we can just keep it less than size. So that's one, you can say, beauty of using traditional loop. But here it is printing all the 10 element. See, these are 5 actual data and remainings are 000. You can use while loop, you can use do while loop as you wish. If you want to use while loop, let me just write down a while loop for you. So first, in while loop, first we have initialization out of the while loop. In while loop, we can simply write the condition. So I less than size, simple. And within while loop, we can print I, and within this also we update. That's it. You run this and you get the output. See, you can use do while loop as well. So you try out with all the loops, right? Now this is simple traversing. I'm just removing these loops. I'm just keeping the traditional loop for traversal. That's it. So now let's go for insertion. So first let's insert at beginning in the array, and let's pass the size as well. So we have to take here one more method. Insert at beginning, and same we take the same thing. I just copy paste this only. ARR1 and the size. Right? How to insert at beginning? And see, for this, for traversal, we know, if you want to find out, let's just comment out this time complexity for this complete thing. So we know for this, the memory would be allocated for this. These are order of 1 only. We are inserting the data here. So order of 1, 1, 1, 1, something like this. And we are calling this. So for this method, call would be here, and here also we have. Now this is the loop. So mainly this line would be printed. I mean, how many number of operations are there? Till from 0 to size. Size is 5. So now it depends basically on the size. So actually size may be 10, 20, 50, and there can be any number of size. So order of n. So mainly while calculating time complexity, we just care about the loops, recursion, method calls. That's it. We are not, more concerned about these simple statements because these are of constant time. So time complexity would be order of n only. Now insert at beginning. And the case is I want to preserve the relative ordering of the elements, right? We are given the size as well. So what you need to do, let's just write down a loop and what element you want to insert, that also. So here pass the element as well. Suppose I want to insert here 30 or 89. So here we need one more int x. X I want to insert. So I would be started from the size I greater than 0 and I minus minus. We know we run the loop till here. So array 1 of I is equal to whatever array 1 of I minus 1. Simple. And once you reach at the beginning, just insert here whatever the x value is. Yes, simple. And do one thing. See, let's see if I am doing here size plus plus. Okay, here I'm writing size plus plus. Fine. Now we have inserted this 89 and now traverse the array again. So just call again traverse array, whatever the array, comma, size, whatever the size. What do you think? What output you will get here? Please pause the video and think about this. We have this array, traverse array, then we are inserting at the beginning and then again we are traversing the array. So this is for traversal of the array and this is insert at beginning. What output you will get? Dry run this program because there is some mistake in this program. You will not get the expected output. And once you dry run this, then only you will get to what is the mistake and then only you will learn. Don't just think that, ma'am, you just correct out and we get it. No. Please pause the video and just try run this and see what the mistake is there. Let's run this. Okay, we have traversed the very first. So let's just comment out this. First insert and then traverse only once. So after inserting 89, the array is something like this. The array was 10, 5, 16, 19, 1. After inserting 89, it should be 89, 10, then 16, then 19. But where is 1? There is no 1 here. So what is happening here? We have done size plus plus as well. Still, it is not running. It is printing only the 5 element, not 6 element. What is the mistake here? Because we have done size plus plus within this method. So this is local to this. The size, I have told you that in array there is everything is called by value. Call by value means the copy of the size is to be passed. So here is one more variable size, a duplicate of this size. And whatever updation is done in size plus plus, that is in this duplicate on the copy of that size. And once you return from this, all the changes in the 5 that you have updated this plus plus, so this becomes 6, this would be destroyed. And there is no change in the actual date. So that's why here size remains 5. So that's why it is not printing. So that is the mistake. You have to do size plus plus here only. After calling this, now size plus plus, now traverse. Now you will see. You get the 1 as well at in the output. See. Now don't think that, ma'am, you are passing array also pass by call by it's also you are passing as a copy means call by value only. Then why this array has been updated? Because this is array 1, so this should be the copy and should be updated in array 1 only and this array should be as it is. It's because in ARR this is reference variable. So we are passing the address mainly, we can say. So address is here. So using address, we can access the actual object as well. Although it is called by value, not passed by called by reference or passed by reference, it's passed by value only, but still this is the address and it is pointing to this actual object in the heap only. That's why this actual array would be updated, but the size is not that much that thing because size is the local, it's not any object, it's just a simple variable, so that would be created in stack only, not heap, and just a copy would be passed and that's why size would not be updated. I hope you got this. But what if suppose the size is not given to you? Now you have to update this. Size is not given, insert at beginning, so I cannot provide you the size. I just can give you the array and whatever I want to insert 89. So there is no size. Now what will happen? There is no size here. Just I'll give you array and this. Now it's not, it's like that. Maybe you just run till length. Okay, just run till here. Let's find out array 1 dot length and then this and then this. Okay, maybe it will work. Here also, let's suppose we are not passing any size. Let's change it. We are passing only ARR. There is no size, and while traversing also we are traversing the loop till the length of the array. Okay, let's run this. Let's see. You will get the see array index up to bound exception. Once you click here, okay, Here we have, and okay, it is index out of bound because array length is 10. So I would be 10. A of array of 10 we cannot access because index is 0 to 9. So it would be length minus 1 in this case while traversing. Now let's run this. You get the output. 89 would be inserted and everything you get. But what is the use to traverse the array till the length? Because suppose here we have 100 elements. In that case, what will happen? Till length of the array, till 0 to 99. See, 0, 0, 0, how many zeros are there? So this is wastage of the those CPU cycle or the computation. Why we are computing? We just have, you have to deal with the actual data. You don't need to deal with these 0, 0, 0. So that's why the size matters here. But size is not given. Now what will I do? You have to count the number of actual, the elements in this array. For that, we can just write down one more loop here in the inside at the beginning. First count the number of elements. So we can just use for each loop int I and AR are 1 in this array. If whatever the I, or let's not take it I, you maybe misunderstood this. This is the control variable in this. So in for each loop, there is no control variable. So let's make it num only. Num not equal to 0. Till then we will do, we just take here a count variable int count, and at first count is 0. You have to initialize this. So count plus plus, just to count plus plus. That's it. I just consider that this 0 is not a valid data in your array. It is because by default, if there is no data in the unfilled space, we know that by default it would be 0. So we assume that 0 means empty space in this case. If you consider 0 as valid data, like 0 is also a valid data in your case, 10, 0, 16, 19, 1, then in that case, this will not work. As soon as it will find 0, it will stop counting. But that's not the case. So here, one thing I just consider that 0 means unused space. One more case can be there if you want to consider 0 as valid data. At first, you can do one thing, you fill the array with some like minimum integer value or maximum integer value using wrapper classes, right? So that also you can do in that case. So there you can print the value not equal to that integer dot min integer value till then count plus plus, whatever value you want to fill. But here I want to consider 0 is not a valid data here. So suppose here we have 7. Now num not equal to 0 till then count plus plus. Else not count, just break. Simple. See what happens if you will not write the cells. Let's remove the cells and I'll show you the difference. What will happen? So I have just counted the number of elements. At first count was 0. In array 1, I was having number of elements are 10. Then we have 7, 16, 19 and 1. Okay. Now at first 10 would be assigned to this num. So num is not equal to 0. Yes, condition true. Count plus plus. Now count becomes 1. Again now 7 would be given, would be assigned to this num. Num not equal to 0. Yes, count becomes 2, like this. Then 3, then 4, then 5. As soon as it move forward, now remaining elements in are 0, 0, 0. Remaining 5 elements. So next is 0. After count becomes 5. Now 0 would be assigned to num. Is this condition true? This condition is not true. But the thing happens is condition is not true. So it will not do count plus plus. But it would be out of this if. But still in array there are remaining parts. So this for each loop will run till the end of the array. Till the length of the array. Again, this 0 would be assigned, condition not true. Again, this 0 would be assigned, condition not true. Again, this 0 would be assigned, condition not true. Again, this 0 would be assigned, condition not true. No count plus plus. But why to count these things? Once you get the first 0, just stop now. Because after that, you will be 0, 0, 0 only. So you will not do any count plus plus. So this is some unnecessary computation you are doing. So as soon as you get first 0, this condition not true. stop. But one thing now you can do, there is no else part and all, so it will move till the end, right? So that's why I'm just writing here else. Else break means we know out of the loop. Simple. So once the first condition give first 0 would be assigned to num, this condition not true, so control will go to the else part. Break means out of the loop. You will not do the computation till end of the this till the length of the array. That's why I was just writing else break. I hope you got the this meaning of this. If you don't write, there would be no error in this kind of thing. Your program will run. But this is like some, you can say, improvement in your code. You have to take care of these things. It would be, reflected once maybe you are there at the interview desk. So if you write this code, else this, then they'll understand, okay, you get actually the working of this for each loop. That's why you are writing this break. Okay, so this will give you some extra, you can say, edge, or maybe extra points in the interview. Now that's it. This is how we have counted the number of elements. Now we have count 5, or you can say not count. If you do not take this count, just take its size as it is, so that we don't need to change anything else. So now size is 5. Now we got the size. So we know that no need to run till the length. Why to run? Just keep it till size and greater than 0, and that's it. Simple, right? Here we are not passing any size. Same here while traversing also. Why to traverse till the length of the array? For just control C, and here we just to calculate the size of the array, actual size of the array, and then simply run till the size less than size. Simple. Now if I run this, let's see. Okay, you got it. We're not passing any size, but still you got it. But extra loop you have added, some extra computation is there. This loop will also run now order of n. So for this also order of n, this line would be executed. This else would be order of 1 only. This would be again order of n, and this would be order of 1. So n plus n, 2n, 1 plus 1, 2. So order of 2n plus 2. Exact time complexity if somebody wants, you can do this thing. Okay, 2n plus 3, because this line is also there. For this function only, for this method only, I'm telling you. Simple for this method. Sometimes in interviewer, they don't ask for the complete program. They'll give you, just write down the method for this and just tell me this time complexity. By this only, they'll have the idea that you have the knowledge of time complexity and all, or not. So order of 1 for this line, order of n here, then order of 1 again for else, then order of n here, then order of 1 for this. So I think 2n plus 3. That's it. And in general, order of n only. So this is how we can insert at the beginning. And if you want to debug this, you just add some debugging points here, breakpoints. I mean those breakpoints, and you can just debug this, right click, debug the operation and all. So you get an idea what actually is happening. Okay, this thing you can also do. So here I want to debug. Suppose let's just remove this else and then debug this. So I'll add some breakpoint here in the main, here. So let's debug this. So at first the control is here in the main at the first line, because this is the breakpoint. So this is going to be stopped here at first. Now we have to step over. Now control is here. Step over, step over. See the arrays 10, then 7. After this we are having 10, 7, 16, then 19, then 1. Now this method is going to be called. So array is this. Remaining are 0, 0, 0. Size is, oh, we have taken 100. We are just wasting the space. Let's step over. Now we are at this function. So size is 0. Step over. Now this C. Array is this. X is 89 and size is 0. 3 variables we have. On console we don't have anything right now. Step over. This C. This condition true? Yes. Num is 10. So increase the size. So size becomes now, see, once you step over, size becomes 1 here. In this case, size is 1. See here. Step over. Now size becomes 2, right? Again step over. Now size becomes 3. Again step over. Now size becomes 4. Again. Now size becomes 5. Now again. See, num is 0. Num is 0. This condition is false because not equal to 0, but it is 0. It's false. So now there would be no size plus plus. Once you step over, control will again be to this line. Go to this line. Again 0 would be assigned, size is still 5. See, again 0 would be assigned, again false. There is no plus plus. Again 0 would be assigned. So this is like wastage of these computation. The exact thing is we have to break. We should break here. Once we get the first 0, we should break. But it will run till the length of this array. See. But actually we have taken now, sorry, the length of the array is 100. So obviously it is going to take so much of time. It will run till 100. So that's exactly I just wanted to show you. That's why we have taken here L. So let's just stop it in between. You can just debug this with this. You just take here 10 elements and then debug this. Okay. So I hope you got this now. How to insert at the beginning. Once size is given and size is not given, and you have to calculate you have to count the number of elements, right? And where to write this size plus plus, when to increase the size. Now insert at the end. Let's take one more method here. Insert at end and 90 I want to insert. So let's take a method here. One more thing. See, if size of the array is here, we have only 6. So okay, there are 5 elements. We can insert at the beginning. It's fine. It will run. Let's just don't call this. Let's run this. So it will, obviously it will be like something like this. Okay. Again, I want to insert one more thing, one more element. So suppose again I want to call insert at the beginning only, and element is this. And then again I want to print the array, means traverse the array. That's it. Let's run this. Now you will get an exception. See, array index out of bound exception. Because index 6 is out of bound for length 6. Array length is 6 only, and previously there were 5 elements. You have inserted one element. So the array is full. Array is full now. And again you want to insert. So array index out of bound exception you will get. So here only what you can do, you can just print some if else statement. If the size or the size of the array, after calculating the size, if the size of the array, here you can write down one thing. If the size of the array is greater than or equal to whatever the array dot length, then you just write down something that we can't insert, array is full. Or if you don't want to write something like this, to handle the exception, we know we can do exception handling. So better to write this code in try catch block. So before this, we just write down try. After writing this complete thing, just add a catch block. And which exception can be there? Array index out of bound exception. So it will simply catch. You don't have to worry about this. Simple. If I run this now, you will get first time it would be inserted successfully. See, and now array index out of bound exception. Same array would be printed because after calling this, we are again printing the array. Okay, so better to handle the exception as well, right? Now insert at the end. Let's just remove this thing, and now we are inserting at the end. So we write this also in the try catch block, and after this we are having catch exception, or specifically if you want to catch array index out of bound exception. So I want to catch it and I just want to print it whatever the e is, or custom message also you can print like the array is full, we cannot insert any other element. Like this also we can print here. First, we are not passing any size here. So one thing, first you have to calculate the size. So this is for sure. I've told you if size is given, it's very simple. That's why I'm just telling you. If size is not given, then what will happen? You have to count the size. So there is one extra loop you have to write. Now, at the end, so we have counted this thing. So we have the size now. So we can simply write whatever ARR of 1 and whatever the size is equal to X. Simple. And after the end, just here we increase the size. So, okay, there is no size here. So just here we have to increase the size plus plus. Simple. Now just make it 10. And now traverse the array again. Let's print it. Let's run this. First, it will insert 89 at the beginning. And 2 times, why it is printing 2 times? Okay, 2 times you are getting insert and insert. Sorry, insert this. So we have to do something here in the traverse. After printing this, let's add a new line. Now run this. Now it will print in 2 lines separately. So first we have inserted 89 and then at the last 90. So we're done. Yes. And see, in this case, if the relative ordering, one more case I want to tell you, if you want to insert it at the beginning and the ordering doesn't matter, ordering of these element doesn't matter. So what we can do? We can insert here 20 simply like this. We can do 20 here and 10 would be directly at the end. We just move this at the end. We don't move these things. So for that, what we do? First count simple and then you have to write down 2 lines only. There is no this kind of loop and all. Okay. So I just show you here. I'll not run this, but I'll show you. You can just run this. So you just write something like this, like ARR of 1 and whatever the size at the end, just move ARR of 0 first. And then at the 0th position, just write down whatever the X. These 2 lines you need. Simple. Okay. If the ordering doesn't matter in that case. So in this case also there is no this kind of loop you require. So you can just comment out this. But here we have one loop. So order of one, an operation is there and this is order of 1 only. So if you are given the size, suppose size is given, so you don't need to write down this loop as well. You can just comment out this. If size is given. In the previous case, the size was given here. Size is 5. So if size is given, so you can simply, you need to write down these two statements. So inserting at the beginning, if size is given and the ordering doesn't matter, will take only time complexity would be order of 1 only. There is, it doesn't dependent on the, you can say that it doesn't iterate anything like these statements are not executing n number of times or the input size. So it would be order of 1 only. So it depends how many type of questions has been asked to you in the interview. Depend based on that you have to answer the time complexity and all accordingly. Okay. It's not like that ma'am has given the time complexity in insert at beginning would be order of n. And maybe this kind of situation is given to you. So in this case, it's order of 1. So you have to analyze what is the situation, what is the approach, how you have written the method. According to that, you have to analyze the time complexity and space complexity, right? I'm just removing this from here and just uncomment this thing. So insert at specific position now. The third thing, I want to insert at a position. So you have to give position. Position I'm giving suppose 3. And I want to insert the element is 100. I mean the value is 100. At position 3 I want to insert. Let's just create here one more method. So here we need 3 parameters because we are passing 3 argument, array, then position, then x also the value. So position and x. Position I am considering different from index, right? Okay. Now first same. If no size is given, you have to count the number of elements. So the same loop. In try only, I'm going to write this thing. So just copy paste this. So first let's write down catch. at the end of this try. Simple. So we have calculated the size, actual size. Now, at a position I want to insert. So at position 3, so the loop would run till obviously till from position till the end of the array, right? So we have int I is equal to whatever the size, and it's greater than equal to whatever the position, and then I minus minus. We simply do array arr of, here what we have to write, I is equal to whatever the arr1 of I minus 1. We just assign this thing. I guess we are done. And then arr of 1 and whatever the position minus 1, because I'm considering position is different, index is different. Position minus 1 equal to whatever the x value is. Simple. And then size plus plus. Right? But here one more thing. You have to put something. If position is not the valid position, so before writing the for loop, you have to put if this position is less than or equal to 0, or position is greater than, what was the condition, greater than whatever the size plus 1. If this is the case, simply print position is not valid, and in else part just write down this thing, this for loop. Else, okay, just do the inserting kind of thing, this logic. So position is 3 and x is this, and after this let's again traverse the array, run this. At first we have inserted 89, then 90 at the last, and at third position now 100. So see, first, second, third, 100, and like this. I hope you got this now. Same, you can calculate the time complexity for this method only if you want to calculate for this insert at position only. Then we have this loop. So for this, it's order of 1 for this line. Now within this loop, this comparison would be done, checking would be done. How many times? Order of n times only, because it depends on the, you can say that length of the array, size of the array. So order of n, and this is order of 1. So basically this is order of n. Else part, for the else part it's order of 1 only. For this also it's order of 1 only. I mean these operations would be checked one time. So it's basically for this also, for complete we can write order of 1. In else part now come again for loop. So generally till from size till position. So in worst case it can run n times. So this would be done till n times. So it would be again order of n only. It depends on the size. This is order of 1, this is again order of 1. So if you calculate after doing plus plus plus, you just count this. So here we have 1, 2, n, and we have like 1, then 2, then 3, then 4, then 5. So I guess 2n plus 5, something like this. But we take is order of n, right? But if size is given, then you don't need to write out this loop, we know. We directly check the position. Else, here size is given, so we don't have to calculate the size. Simply you can write your size. Just pass here size as well. And if space complexity you want to calculate specifically for this method only, in interview they ask this thing. So we don't have any array kind of thing here. For this, we have order of 1. For this variable, order of 1. For this variable, order of 1. So size also order of 1 we have. So we are taking num also order of 1. Then there is no extra thing we are taking here. Okay. So space complexity is order of constant 1, like 1, 2, 3, then we have 5, then we have 6. So we can say order of 6. and generally order of 1. But if for complete program, it will ask, so we have this array itself. So for, you can say, having this array, we have whatever the number of elements in this array. So order of n, you can say, space complexity, input space plus auxiliary space, n plus 5. Okay, so we are done with the insertion. Here in this ppt, okay, one more way is we can give we can take an extra array. Suppose, see here in this example, they have taken extra array. So in this array, 1 2 3 4 5, new element you want to insert 0, but there is no space in this array. So let's make a new array of size numbers dot length plus 1. Increase the size by 1 because I want to insert a new element. And new array is 0 because at the beginning I want to insert is equal to whatever the new element, and then copy all the old element array to the new element. So a new array. So from 0 till numbers dot length. Numbers is the previous array, so numbers dot length I plus plus, and just copy. Start with I plus 1 because at ith, at 0th index, we have the new element. So here extra space, auxiliary space required is order of n because we have taken a new array as well. So one input space order of n, auxiliary space is also order of n. And for element, new element, order of 1, for I order of 1. So like this. So order of n time and space is also order of n because we have taken a new array. So whatever example here we have given in this PPT, they have taken a new array itself. But in this program, actually we have done this exercise. There we haven't taken any new array. We have just updated the same array only, just to save the space. Okay, but this is one more case. If programmers say that you have to take a new array, you can take a new array as well, right? So now let's see deletion. Same deletion from the beginning, from the end, and from the any specific position. Let's see. So first, let's discuss how to delete from beginning. I want to delete this element from this array. So I cannot simply delete this. We can't leave something like this. There's some space and then we have array. No. Array should be from the starting in a consecutive space. So you have to shift this to here, then here, then here, and then here. And at previously, if size was 5, now size becomes 4. So here you have to do size minus minus, simple. I guess that's not a big deal. You can easily do this thing. How to write down this for loop. You can just pause the video and try this out now. Okay. How to write? If size is given, if size is not given, first count the number of elements. I have told you how to count, and that's it. And if size is given, for now, I will just consider that size is given to you. Size is at first 5. Okay. I want to delete this. So you have to shift all the element to the left to fill the gap. If there are 500 elements, so you have to shift all the 500 elements. So that is the worst case. If you want to delete from the beginning, so that's like the worst case. You shift all the elements. So time complexity would be, I guess you can easily guess, it's order of n. Okay. Smart. Now, how to shift? So we just have one thing, int. So we can simply start shifting from here only because we don't want this data. We want to delete this. So we just override this. So 1 here, then 2, then 5, then like something like this. So start from here and go from here to here. While deleting, shift here. While inserting, we start from here and move backward. So int I would be 0 only, and I would be less than whatever the, we can say, size. Let's see this will work or not. And I plus plus. Now we have array of I is equal to array of I plus 1. Simple. Yes. And whatever in the last, like array of size, if you want to put a 0 here, you can just put and just do size minus minus 1. That's it. At the last, 0. So let's see what is happening here. At first, I is 0. Just try run this. Condition true. because size is 5. Yes, condition 2, enter here. Now, what will happen? ARR of 0 is equal to ARR of I plus 1, that is 1. So whatever is in the 1, it would be shifted, it would be assigned to ARR of 1, ARR of 0, like the 0th index. So here we have now 1. Yes. Now I plus plus, I becomes 1. Condition true? Yes. Again enter here. Again this statement would be executed. So 1, and at this time we have a ARR of 2. So now here we have 2. Now I plus plus, I becomes 2. Condition still true. Again enter here. Again this condition would be executed. Now what is that third index would be shifted to second. So here we have 5. Yes. Again it's 3. Condition still true. Again enter here. So now again this condition would be executed. Now we have this side 3 and this side we have 4. So whatever here, this would be shifted here. So this becomes 6 now. Do we need to shift now? Seriously, if you need to any shifting now? I guess no. So right now I want to stop. So once I becomes now 2, it should stop. But if, sorry, not 2, it's I plus plus. So it's 4. But still 4 is less than 5. So it will run one more time. And now it will do what? ARR of 4 is equal to ARR of 5. At 5, we have obviously 0. So 0 would be shifted to here. 0. That can also be a case. It's okay. It's not like that it is incorrect. It will work fine. Now once it becomes 5, condition is not true and exit. But we don't need to actually shift this thing. Here we have 6, here we have 6. We can do simply like ARR of size. Now size is what? 5. So at 5, sorry, here after shifting here, ARR of its size minus 1 is equal to 0. We can just put it's a 0 and then size minus minus. Simply we can do this thing. Or you can just run till here only. Or you can just run till I less than size minus 1. That will also work. Size minus 1. Right? So more precisely if you want to write, you can write here size minus 1. This loop will run till here. And here it should be, if you want to put size minus 1 is equal to 0. Size is 5. 5 minus 1 is 4. So here I just want to put 0. Because we have shifted this side. And size minus minus only. Simple. And size, time complexity, order of n. Space complexity, for input space, order of n. To store the array, auxiliary space, we are taking only I here, extra variable, so it's order of 1. Simple. So order of n plus 1, it's order of n only. For simple this method or this thing, if space complexity is required, generally they ask only about the auxiliary space, what extra space you have taken. In that case, it's order of 1 only. No extra array or something like this we have taken. Okay. So now this is delete from the beginning. Now one more thing I want to show you, delete from the end. So this is the worst case. If you want to delete from the beginning, then you have to shift all the things, all the elements to the left to fill the gap. So this is the worst case. I want to delete from the end. So that is the best case. I want to delete this 7. Size is given to you. It's 5. I want to delete this 5. Delete from the end. Delete from end. This is the best case. Simply delete this. Simply insert here 0 and size minus minus. That's it. Deletion. If size is given. You know size is given. So there are 5 elements only. If size is not given, then you have to count. That is a separate case. The number of elements and simple like this. But simply deletion. You can simply write if size is given like ARR of size is, we know 5. So ARR of size minus 1 is equal to 0. And just to size minus minus, simple. These two lines. So time complexity would be order of 1 only. It doesn't depend on the input size and all the simple in this case. But if size is not given, then you have to count from here to here. Then same, you have to traverse this array For traversal, we need order of n. So in that case, time complexity would be order of n. So it depends which approach you are following and what is happening, what is given into that problem. According to that, it would be decided. So it's very simple from the end. Okay, it is the best case. Now from a specific position I want to delete. In that case, what will happen? See. So same I want to delete from a position second. So 1, 2, 3, 4, 5. I'm taking position is different, index is different. This is index. You can pass index as well. Like from this index I want to delete. So same you can delete from this index, like from index 2. So this would be deleted. From position 2. So from me, for my side, I just won't consider position is different. So position is 2. So I will delete this one from index 1. Now, if I want to delete from position 2, that is this one. So after deleting this, we cannot leave it something like this. What you have to do? Shift these things to the left side to fill the gap. So loop will run from here till the end. Simple. And we have the size. So loop will run till if I is equal to from here, whatever the you can say position. Position is to this. So from here loop will run. But index is 1. So position minus 1. Index is different. And I should be less than size. Or I guess size minus 1. Let's say size minus 1 and I plus plus. Now, when we try run this, we'll see this condition is correct or not. ARR of I, because I at first is position minus 1. So I is at first 1. So ARR of I is equal to ARR of I plus 1. Just shift this. That's it. Simple. And at the last, just insert 0 and size minus minus. Simple. Size minus minus and ARR of this first size minus 1 is equal to 0. Now let's see. Let's try run this. First I is position minus 1. So I is equal to 1 at first. Position is 2. Okay, condition true. Size minus 1. Size is 5. So this would be 4. Condition true. Okay. Control will enter here. Now, array of 1 is equal to array of 2. So this would be shifted here. This becomes 5. I becomes I plus plus 2. Condition true. Yes. Again enter here. Now, array of 2 is equal to array of 3. So this would be here. So here we have 6. I is 3. Condition true. Yes. Again enter here. Now what will happen? Now array of 3 is equal to array of 4. 4 and this would be shifted. Now it becomes 7. Now I plus plus I becomes 4. Condition true? No. Okay, we don't need any shifting now because you are done. We don't need this data. We don't need to shift this. If you want to shift, you can shift. Otherwise, size minus 1 is fine. If you want to run till size, that will also work. Right? Now, what will happen? Now we are out of this loop and size minus 1 is 0. So size is 5. 5 minus 1 is 4. So here we insert 0 and size minus minus. So size now becomes 4. So till here. Simple. So traverse this till here. So this is how it will work. But if position is not valid, you have to check. Like if position is less than equal to 0 or position is greater than same that size plus 1 or size. Size is 5. So you can delete from here. If position is 5, it's fine. It will delete. If position is 6, there is no data. What to delete? So position should be less than, if less than equal to 0 or greater than size. Equal to size is possible, greater than size is not possible. Then you print something like position is not valid, something kind of this kind of thing. So here also same complexity would be order of n time complexity because we are obviously shifting the data, right? So let's just try to run these programs. So you can pause the video right now and just try to run these on your laptop. Okay, so here let me just create a new Java class here. Deletion on array. Let's create a new class. So we have in same array. Let's take the same array here. Same size is given 5 and we have this much of data in the array. Now I want to delete, or suppose I don't have anything in this array. Right, there is no size. Now I want to insert from the beginning only, from 0 1 2 3, something like this. Now what to do? Can I call that insert at specific position? Let's call that. We have, see, we have in this insert at position, so we can give position 0 as well, no? So that will insert at the beginning only. So we call this method from this, because this method is we can say it's not any, like we haven't given any access specifier, so by default it's a package private. So within the same package I can access, and deletion is also within the same package. So insert at position, and whatever the array that will pass, and 0 and 10 I want to insert, but this will give error. See, cannot resolve this method. You have to import. You have to import this. So import this. So better to import everything from this operation on arrays from this class. So what we do is, rather than importing a specific this method only, let's import everything. So import arrays dot asterisk. So everything would be imported from this class, right? Now let's delete this. So insert at position 0 and 10. So it will call this method from this class, from this program, right? These are within same package, so we can do this thing. So insert at position this. And if this method is public, then we can access this method from any other class which is not in this package. But this is now package private, so we can access within this package only. Insert at position 0 this, and let's call traverse also. So we have there traverse array. ARR, simple. We are going to traverse this. Let's run this and see what will happen. Okay, position is not valid. Why so? Because position is 0. So position, there is no position 0. Position start from 1, we know. So you have to delete this and give position 1. Then it will insert at 0th index. So it will print 10 only. Fine. If I insert at position 2 and then again traverse array, or after inserting 2 3 elements, suppose 3 elements or 4 elements, at position 3, then at position 4 I want to insert some elements, and then traverse the array. So it will print 10 20 1 5. So 10 20 1 5, right? Let's delete this one. So like this, if the array is empty and you want to insert something, so simply we can insert using this, calling this method as well. Just pass the position and all. But see, if I pass here same position 1, in that case what will happen? Already we have 10. So in the array we have 10 in first position. I want to insert at the beginning. So what will happen? It will shift the 10 to here and 20 would be here. So it would be something like this. Then I want to insert at third position. So 1, 2, 3. Okay, in this case it will be 20, then 10, then 1. And then in this case it would be 20, then 10, then 1. And at fourth position is 5. I guess this would be the output. Let's run this and see. 20, 10, 1, 5. Yes. Okay, fine. We have inserted 4 things. So now I have this thing in my array. 4 elements are there. Now I want to delete. Delete from beginning. So let's have here a method void delete from beginning, and let's take an array. So obviously we want to delete from beginning only, so we can easily delete. We just have to shift. So if size is given, then no need to worry, but size is not given here, so you have to calculate first the size. So for that we know we have this, and we have to use this try catch block also. So just write down this thing first. In try, just calculate the size first, right? And after this, obviously, you have to write down a catch block. So let me just first write down. Okay, now we have calculated the size. Now from the beginning, if you want to delete, you just have to write down one loop for int I. From the beginning, I want to delete. So you have to shift. So from 0th position only start. And this I should be less than whatever the size minus 1, I plus plus. And ARR of 1 and whatever the size minus 1, just 0. And just do size minus minus. Simple, because we have deleted one element, right? Now after deletion from the beginning, let's again traverse the array. Traverse array. Whatever the array is, let's traverse that. Okay, run this. So first 10, 20, 1, 5, and after deleting from the beginning, it's 10, 1, 5. Yeah, it's fine. 20 has been deleted. So we got this from the beginning. Now let's delete from the end. Delete from end. So let's create a method here. Delete from end, and here you just have to pass. So in this case, size is not given, so we cannot simply write that size kind of thing. If size is given, you just have to write down only 2 lines, that's it. But suppose size is not given, so first calculate the size here. Let's just copy paste everything from this. And what you need is let's calculate the size, that's fine, but we don't need this for loop here. Delete this. Size minus minus, obviously we need. Now from the end I want to delete. So after calculating the size, what you need to do, whatever the array 1 and that size minus 1 is equal to 0, and just do size minus minus 1, that's it. So we simply write this thing, size minus minus, and that's it. After delete from end, let's again traverse the array and run this. So at first it's this, then after deleting from beginning it's 10, 1, 5, after deleting from end it's 10 and 1, that's it. Very good. If the size was given, you no need to write this thing, you need only 2 lines, that's it. So it will take order of 1 only, right? Now delete from any position. Now let me just show you, if size is given, then what will happen. Suppose let's take, we have at first we have size is equal to 0, there is nothing in this array, so size is equal to 0, right? Insert at position this, and then after inserting we have to do size plus plus here also. So this would happen here again, size plus plus, then for this also size plus plus and size plus plus. Reversing the array. Okay, now delete from position. From third position I want to delete. Let's just comment out everything. We have this array only. I'm from third position. So 1, 2, 3. 1, 2, 3. So this one I want to delete. So only one shifting is there. Let's have a method here. So we're passing 2 arguments. So we have to take 2 parameters for this. First, from position, if you want to delete, obviously first we don't have any size kind of thing. So we have to calculate the number of elements. We know how to calculate. We have, let's just copy paste everything. This method delete from end. Whatever we need, we take it, otherwise we remove it. So we need this thing, calculated the size. Now we don't need this thing, let's just remove this. Catch we need, okay. Now we have to write down your logic. First check if the position is not valid. If position is less than equal to 0, oh sorry, or position is What? Greater than size. Then it's not a valid position, we know. Else. In else part, now position is valid and now we have to write down the logic. So loop will run till I is equal to whatever the position minus 1, because index is always position minus 1. Position is different, index is different. And I should be less than size minus 1, I plus plus. Till then, we are going to change shift. So array 1 of I is equal to array 1 of I plus 1. I plus 1. Right? So I guess we are done. And now I guess we have to put array of whatever the size minus 1 equal to 0, and size minus minus. Simple. Okay, we have to put everything this in else block, right? After 4, let's close this 4, and then this is in else part only. So this is how we can delete from a specific position, calculated the size, and then check the position, and then that's it. Let's see. We are position from third position I want to delete, so let's run this and see what is happening here. Okay, so at first we were having array 10 sorry 20 10 1 5, so from third position, so 1 should be deleted. But yeah, oh, you have to print this now. After deletion you have to print this as well. So let's run this. Now it should print 20 10 and 5, 20 10 and 5. Yeah, get it? So it's working, right? Now if you delete, let's just delete again from position 3. Let's run this. So now at position 3 we are having 5, so 5 would be deleted. Again if you delete from position 3, let's see. There is no position 3 now. So I guess it should give position is not valid, yes. Because there is no position 3. Now we have only 20 10 in the array. Position 1, 2, there is no 3. So how you can delete? Position is not valid and it will print only the array 20 10. And if suppose I want to delete again position 3 but position 1, then we have only one element left now, 10. Let's delete this as well. From position 1. So we have nothing in this array now. Right? 10 has been deleted. Now again if you delete from position 1, let's run this. Position is not valid. And if we do not check in this case, this position is valid or not, let's just comment out this thing. There is no else part. Comment out this. We only have this 4 directly. And now if I run this, then it will give index out of bound exception, because now index would be minus 1. After deleting everything, now index is minus 1, that is out of bound. So if you don't want to write down this thing, it will be handled by the try catch block itself. But suppose if I delete everything and delete from position suppose 9. Now what will happen? Let's run this. So this would not be handled by that. This case would not be handled. So in this, that's why we write down this if else condition here. If you have any other alternative to do this thing, you can just try that out. So just put this if also. I hope you got this now. Same, yeah, like the from a position, if you want to delete, then it would be order of n only. For specific this, order of n for this, order of n for this for loop. So it's 2n ultimately plus some constants. So we take order of n only, we know. So we are done with the deletion. Here also in this PPT you will get a new array. So they have taken an extra array perform insertion and deletion as well, right? So from a new array, we assign length -1 because we want to delete. So it would run till 1 till the numbers dot length, and we will move the copy all the elements except this one to the new array because we are deleting from the beginning. From the end, if you want to delete, just run the loop from 0 to numbers dot length -1 and just copy the elements. That's it. From a specific position, if you want to delete, then before that position, copy the element. For that position, you don't want to copy, and after that position, just copy the element. That's it. Okay. So it's like we are taking a new array in this case. So extra space we are taking. Now, efficiency matters. So in these kind of operations, shifting elements in the array is having time complexity order of n. So it's less efficient for large arrays. We have 10,000 data or 1 million data. So that's why we say that when you need frequently insertion and deletion in the data, then avoid using arrays. So better to use linked list in that case or array list, right? So that's it about this video. I hope you got this. Now practice a lot of these questions, insertion, deletion, traversal, because these are basics, because we'll be moving on for the advanced topics. So we'll be discussing now in the next video what are operation searching, how to perform searching on arrays, then sorting, then we go for array list and then linked list. So that's it for this video. Now I'll see you in the next lecture. Till then, bye bye. Take care.